Good evening. Last time we learned to complete the square on a quadratic that was missing the third term. Today we're going to learn how to use that in order to solve a quadratic by the process of completing the square. But before we do that, just as a quick reminder, what we mean by solve a quadratic is we have this quadratic, x squared plus 5x plus 6 equal to 0. If we can, we hope that we can easily factor this quadratic, right? Hopefully we can just take the time to do two sets of parentheses. Since this is a leading coefficient of 1, find two numbers that multiply to give me 6, but add to give me 5. Well, that's a 2 and a 3. 2 times 3 is 6. 2 plus 3 is 5. We set that equal to 0. Each factor must be set equal to 0 because we want the product to be 0, right? So x will either equal -2 or x will equal -3. So we get those two solutions from the factored form. But the problem is obviously quadratics don't always factor nicely. In other words, this one, -9, there's not two numbers that multiply, two integers that is, that multiply to give you -9 that add to give you a +2, right? That doesn't work. So we need to do a different process. Now, before I go into this process, I want to make sure we understand how easy it is to solve a simple x squared equaling a number. If I say x squared is, I don't care, 9, you should easily know that there are two solutions, by the way. We get an x value of a positive or a negative square root of whatever 9 is, right? So that would give us either a +3 or a -3 as my two solutions. And that's true no matter what's on the other side. So if I give you x squared equals 18, well, that's going to be x equaling a positive or negative square root of 18, which, by the way, we can reduce to a positive or negative 3 square roots of 2. That's reducing this radical because then 18 is a 9 times 2. Square root of 9 is 3. Square root of 2, I don't know. I leave it like that. But I get a positive version and a negative version. Okay, and we could even actually equal a negative number, -5, right? And that's going to equal, x, when I solve it, when I square root, x is going to equal a positive or negative square root of -5. And remember how we do that? It's going to be a positive square root of 5i or a negative square root of 5i. So we can get some complex values now. Another thing I want to emphasize is a lot of times we can actually have something like this, a binomial squared equaling 9. We can solve it the same way. We don't need to FOIL it. We don't need to factor it. All I need to do is say x plus 2 equals a plus or minus square root of 9. Well, that means x plus 2 equals a plus or minus 3. So if it's a plus 3 and then I minus 2 from it, positive 3 minus 2 means I have an x value of 1. If it's a -3, -3 minus 2 would be a -5. So we get a +1 solution and a -5 solution. Maybe I should have did that a little slower. X plus 2 equals a +3, minus 2 minus 2 gave me the 1. X plus 2 equals a -3, right? -2 gives me a -5. And again, that will work no matter what's on the other side. If I give you an x plus 9 in parentheses squared equals, oh, I don't care. Let's do that 18 again. Well, let's make it -18. Okay, -18. Well, then you do x plus 9 equals the plus or minus square root of -18. Well, that means x plus 9 will either equal a positive 3 square roots of 2i, or x plus 9 equals a negative 3 square roots of 2i, and then you minus the 9 over. So x will equal, when I minus the 9 over, a -9 plus 3 square roots of 2i, or x will equal a -9 minus 3 square roots of 2i would be your two complex solutions. Now, think about this. This is a binomial squared. So let's go back to what we're supposed to be learning. How do I make this x plus 2x minus 9 a perfect square? What we're going to do to solve this is we're going to bring the 9 to the right side. So we're going to go x squared plus 2x equals 9. Then what I'm going to do is I'm going to leave enough space. So I probably should have did this the first time, just leave a space, equals 9. I'm going to write an addition of a number here on both sides of this expression, which will keep the equation the same. As long as I add the same amount on both sides, I'm fine. And I'm going to add the number that would make this a trinomial here that's a perfect square, a quadratic that's a perfect square. Remember, I'm going to take half of this number. So what I often do is I go like this, x, I go, what's half of 2? Oh, that's 1. What's 1 squared? I have to have a 1 here, plus 1. But if I add 1 to the left, I'm going to add 1 to the right to keep it equal. So that's going to equal 10. Now I'm going to do what I just taught you on that other page. I'm going to square root both sides. X plus 1 equals the square root, a positive or negative of that, of 10. So x equals, minus it over, a minus 1. I'm minusing that 1 over, plus the square root of 10. Or x equals a minus 1 minus the square root of 10. Those would be your two solutions. And you'd use square roots. You'd write them just like that. So let's do another one. Now, with this one, again, the most important thing about completing the square, though, is this 4 in front of the x squared needs to be a 1. We need a leading coefficient of 1 in order to complete the square. And most likely, everyone they're going to give you, all three of these numbers are divisible by 4. That would be the first thing I ever do. I'm going to divide both sides of this equation by 4, because what's 0 divided by 4? It's still 0. I can do that. I can divide everything by 4 and get me x squared plus 22x plus, that's going to be what, 28, 36, 29 equals 0. Now I'm going to minus the 29 over. So I'm going to go x squared plus 22x, I'm going to leave a space, equals a negative 29. Now, I'm going to take half of this number, which is 11. I'm going to square that 11, which is going to be a 121, and add it as a third term. But I added it to the left. I need to make sure I also add it to the right. So now what's 121 minus 29? Well, it's going to be 90. 11 minus 9 is 92. Now I have a squared term equaling a constant. I can square root both sides. X plus 11 equals a plus or minus square root of 92. So x equals, I'm going to minus the 11 over, minus 11 plus the square root of 92, or x equals minus the 11 over, minus the square root of 92. Now I'm just going to quickly check to make sure this doesn't reduce at all. 92 is obviously divisible by 2. So again, I'm just seeing if there's a factor of 92 that can be square rooted out. 2, that's going to be 46. Yep, so there 4 goes into 92. So 4, and that's going to be 23. So I'm going to square root the factor of 4, and my actual two solutions should be a minus 11 plus 2 square roots of 23, or x equals a minus 11 minus 2 square roots of 23 would be my two solutions. All right, let's do another one. Make sure we can continue to do this. So remember, the first step is if there's any number in front of the x squared, I'm going to divide it out. So I'm going to divide both sides by 3. So that's going to give me x squared plus 42 divided by 3 is going to be 114. X plus 45 divided by 3 is going to be 115 equals 0. 0 divided by 3 is still 0. So this quadratic is the same as this quadratic. Now I'm going to remove this 15. I don't like the 15. 15 is the wrong number to make this a perfect square. So I'm going to go x squared plus 14x, leave a space, equals minus that over 15. Now I'm going to take half of the 14 and put it inside a parentheses that's squared with an x. Half of 14 is 7. That helps me know that the number that goes here will be 49, because 7 squared is 49. But if I added 49 to the left side of the equation, I better add 49 to the right side to keep the equation balanced. Now I'm going to 49 minus 15 is going to be, let's see, 9 minus 5 is 4, 34. Now I have a binomial squared equal a single number. I'm going to square root both sides. So x plus 7 equals a plus or minus square root of 34. Right off the bat, I'm going to see if 34 has a factor. 2 goes into a 1, 17 times. So there's no factor of 34 that can be square rooted. So I'm just going to minus the 7 over. My two solutions will be a minus 7 when I minus these 7 over, plus the square root of 34. And x will equal, again, minus 7. And then a minus square root of 34 would be my two solutions. Now, don't wig out if you get fractional answers. There's nothing wrong with that. First thing I'm going to do here is divide everything by 2, because I don't like, remember, the 2 in front of the x squared I want to go away. That leaves me x squared plus 3x minus 32 equals 0. This 32 is the wrong size, so I'm going to minus, or add it over actually. X squared plus 3x equals 32. Now I'm going to take half of 3. Again, I recommend keeping it as a fraction. 3 over 2 is half of 3, 3 halves. Now when I square 3 halves, I can square 3 and I can square 2 a lot easier than I can square 1.5. So I square 3, get 9, square 2, get 4. If I add 9/4 to the left, I must add 9/4 to the right. Now, again, I got fractions. I got to get a common denominator of 4 when I add those two together, because I got to add them. And I'm going to have, let's see, 32 times 4 is 128. Yep. Over 4 plus 9 over 4. 128 plus 9 is going to be 137 over 4. So that's going to be a 137 over 4. Now I can square root both sides. So I get x plus 3 halves equals a plus or minus the square root of 137 over 4. Now, I can square root the 4. I'm not sure if there's a factor of 137 that square roots. It's not even. 3 doesn't go into it. So if 3 doesn't go into it, 5 doesn't go into it, 13 doesn't go into it, 7 does not go into it. Yep, 7 does. So I think 137 is prime. So what I'm going to do is I'm going to square root the 4. So I'm going to have a square root of 137 over 2 plus or minus. And then I'm going to minus the 3 halves over. So x is equal to a negative 3 halves plus the square root of 37 over 2, or negative 3 halves minus the square root of 37 over 2. Again, if you have any questions, I know the fraction ones will kind of get hard, but if you have questions, please bring them to class and I will walk through them again, this process of completing the square.